The focus of this video lesson is the automobile expense function. Example 1. Celine bought a new car for $33,600. She made a $4,000 down payment and pays $560 each month for 5 years to pay off her loan. She knows from her research that the make and model of the car she purchased straight line depreciates to 0 over 10 years. We're going to do 3 things here. So let's start with creating the expense and depreciation functions. So let's start with our expense function. Now, for our expense function, we know that the starting amount that she's going to pay, so at time 0, is going to be her down payment, or $4,000. So the first coordinate for our function is going to be 0, 4,000. And we know that she's paying $560 each month. Okay, so we know that our slope, or our rate of change, is $560 per month. Okay, so remember, when x is 0, we have our y-intercept. So we have our y-intercept, aka b, and we have our slope. All equations are written in the form that are linear, are written in the form y equals mx plus b. So our equation is y equals 560x plus 4,000, where y represents the amount spent on the car and x represents the number of months that have passed. Now let's look at our depreciation function. So the expense is how much we've spent on the car, and the depreciation is going to show us how much value the car has lost. All right, so she knows from her research that this car will straight line depreciate over 10 years. So we know that at 10 years, the car will be worth about $0. We know that when she originally bought the car was worth $33,600. So the coordinates we have are 10, 0, and 0, 33,600. Let's start by finding our slope. Remember, our slope is y2 minus y1 over x2 minus x1. And in this case, we have x1, y1, x2, y2. So our slope is 33,600 minus 0 over 0 minus 10, which is 33,600 over negative 10, or negative $3,360. So we can say that this car is losing about $3,360 per year. Now, we want to be careful here because we have our depreciation equation written in terms of years, but we have our expense function where x is in terms of months. So what we're going to do is we're going to take this negative $3,360 per year, and we're going to convert it so that it's in the same measurement, same unit of measurement as the expense function. So we're going to divide by 12 months because there's 12 months in a year. So we have our 3,360 per year divided by 12, and we see that this car is losing a value of negative 280, and that's per month. So that we're going to use that for our slope. So remember, our equation is y equals mx plus b. Here we have our m. And then remember, our y-intercept is where x is 0. So x is 0 in this coordinate. So our y-intercept is 33,600. That's the original price of our car. So our equation is y equals negative 280x plus 33,600. Okay, so that's part A. Now let's graph these functions on the same axes using technology. So let's go ahead and use Google Chrome and Desmos. Now we have our 2 equations. Let's jump back just so we remember what they were. y equals 560x plus 4,000. And then our other equation was y equals negative 280x plus, let's look back really quickly, 33,600. Okay, now what you're going to notice is we're not going to see the graph right now because it's too zoomed in. So what we're going to do is we're going to zoom out far enough so that we can see our graph. Now you might have to zoom in different directions for the vertical and horizontal axis. What I do is I take my fingers on the vertical axis or the y-axis and I pinch inward, and that causes it to zoom vertically. And I can do the same horizontally by putting my fingers on the x-axis, and I can zoom horizontally. Okay, so here I can see my graph. All right, so we know here that the y-axis is the value or how much spent on the car, and our x-axis is going to be the number of months. So let's go ahead and let's snip this. And we are going to insert this into our document. So I'm going to go ahead and paste this, and we're going to talk about this on C. So I'm going to paste it both locations, and then let's jump right back in. All right, so we've graphed it. Now, I would note a couple of things. This blue one is our depreciation, which makes sense because remember, to depreciate means to lose value. And our red one is our expense, how much we've spent on the car. Now, if you're sketching these in your notebook, what I recommend is you focus on labeling things like the intercepts, and then just approximating the rest. All right, last part of the example. We want to interpret the region before, at, and after the intersection. In other words, we want to know, what does this section of the graph mean? What does this right section of the graph mean? And what does this intersection here mean? Okay, so let's start with the before. So this is before the expense and depreciation equation intersect. So remember, our blue line is our depreciation, and it represents the value of the car. And the red line represents how much we spent on the car. Now, if you look here, you'll notice in the before section that the value of the car is higher, right, on the graph than how much we've spent on the car. So the before section represents that the value of the car, how much it's worth, is greater than your expense. In other words, you have more value in the car than you spent on the car. So you're not in the hole. Now, the exact opposite is on the after. You'll notice that our expense line is actually higher than our depreciation or our value line. So we will say here, after we have spent more on the car than its current value. And that's problematic, right? Now, what happens at the intersection? So here is our at. Well, at the intersection, that's the sweet point, right? That's the point in which the value of the car and the expense are the same. This might be the point at which you decide to sell or upgrade your car. So oftentimes people will get rid of their car at this point. That way they don't lose money by putting money into a car that is no longer worth what it was. Now it's your turn to try. Try this. Winnie purchased a new car for $54,000. She has determined that its straight line depreciates to zero over 10 years. When she purchased the car, she made an $8,000 down payment and financed the rest with a 4-year loan at 4.875%. You can use the monthly payment formula for the last chapter to determine the monthly payment to the nearest cent. Part A. Create an expense and a depreciation function. Part B. Graph these functions on the same axes using technology. And Part C. Interpret the region before, at, and after the intersection in light of the context of this situation. Give it a try.